First of all, for introduction, deep learning are proven to be useful in a lot of fields these days. It is very obvious that deep learning is always a good method to use in technology. The second one is that deep learning is a subtopic to machine learning because it represents neural network which taken from human nervous system. The third point, convolutional neural network is designed for image recognition. Why? Because convolutional neural network, or known as CNN, has many layers to flow in order to get the results. Let me get you through it. The first layer, which is input layer. So in this case, it is the image taken from the camera, and then it will go to the hidden layer, which is the different type of function, algorithms, and etc. to calculate something in order to get the results. Lastly, which is the output layer. Uh, the output layer is the outcome of the image taken is the same with the image in the database. So the next point is, one of the main idea is to enhance security measurements, because in the world full of digital devices, this world must have a security measurements that can see everywhere. Because when there's poison, there's remedy. So the next one is, if it is involving with face recognition, CNN must always comes with it. Because face recognition is a complex function to identify a specific person or people by detecting their faces from images or videos. Last but not least, in, in order to improve rate of face recognition, the researchers always incorporate Gabo kernels within the CNN, because Gabo filters are capable of getting multi-orientation information from a face image at a few scales. Lastly, to classify vehicles, CNN is also chosen for the same reason as face recognition I just explained just now. So next, for methodology. So we search throughout the internet with keyword deep learning and image, but only in IEEE Explore and Association for Computer Machinery (ACM) Digital Library. We find all 5 journals in those 2 digital libraries. IEEE Explore is a known journal website that contains a lot about computer science, electrical engineering and electronics, and applied field papers. So the next digital library, which is ACM. ACM is a society based in United States for computing digital libraries. So next, we go to the results. So first, about publication date. From all 5 journals, 2 of them from 2016, 1 of them from 2017, and the other 2 is from 2019. So next, we go to author. 2 of them from China, 1 of them from United States, 1 of them from India, and the last one from Myanmar. So the last one, which is Autos Venue, which is the library I just stated just now, which is IEE Explore and ACM Digital Library.
Next, we will move to research problem. The papers discuss a few problems that coincided with the usage of CNN and camera surveillance. There are potentials to be unlocked for camera surveillance if this problem could be solved. Let's talk about distinctions in the images. So there are irrelevant parts, the uninterested parts, in the images when we put into the CNN. The CNN will also process those parts which, like, if we input if we input vehicle images, all we need only the parts of the vehicle, but the irrelevant parts such as the roads, the trees, the backgrounds of the vehicle also will be calculated by the CNN. So this will be considered ways for the CNN to calculate them. Next is the quality of the images. So a great quality of image of faces is one of the necessity and essential for the recognition of faces. So researchers have to consider the noises and the resolution, because they need and need to recognize the faces without these noises and bad resolution, because sometimes the best system can fall apart if the quality of the images decreases. Next, variation in illumination, pose, facial expression, occlusion, and scale can affect face recognition, because different illuminations such as too bright or too dark can have a drastic negation in the rate of face recognition. Poses, like different pose from left to right, facial expression also can have a different meaning, can have a different calculation between the same person, which is they are doing the sad or anger, could uh, could point them as different face, even though they both are from the same person. And also occlusion and scale, which is like this too big of an image or too small of a face image can have differences between them.
Firstly, the solution that we found is convolutional neural network with physical and visual features. By combining these two features, a higher performance of classification can be achieved, such as shown by experiment carried by Thagarajan, as he used these two features to classify vehicles according to their classes. Second, classification with transfer learning. By using this method, a better performance and accuracy of classification can be achieved. This is shown by experiment carried by Wang, where he used a large-scale annotated web nature data to train CNN. Third, using visual attraction module before CNN. This method can efficiently use convolutional neural network by ignoring uninterested area. The experiment carried by Zhao show how this process works. Next, by using Gabor filter and convolutional neural network, face recognition rate can be improved drastically by using this method. This is because Gabor filter appears to be an efficient tool for facial feature extraction. Lastly, using mobile FaceNet. Mobile FaceNet is one of a lightweight models. There are many types of lightweight models, but it appears mobile FaceNet can give a high accuracy for real-time face recognition. This happens due to two types of depth-wise convolutional separable are used to overcome the degrading of accuracy in later layers.
In conclusion, camera surveillance system can be improved by applying this solution, such as applying physical features, and visual features, which is the physical features is the measurement of the vehicle, and visual features is extracted from the CNN. Using transfer learning, which is we train the CNN with web data instead of the images taken from the camera surveillance themselves, using a module that darken the uninterested area so that the CNN only calculate the vehicle images only without the uninterested parts, the irrelevant parts such as the roads and the background of the background of the vehicle. And also using Gabo filter and using mobile testnets uh, when recognizing face with CNN. We know that there will be far more better solutions in near future as the deep learning will continue to be developed, and also there is no perfect solutions because to improve this system. uh, every system has its flaws, but we can further improve them, and these solutions have the have their points and their critical parts that can be further researched and thus improve the security by using deep learning.